Let us go to part C. Part B is independent of part C. Now part C says, at what instance are the velocity and acceleration 0 in a motion defined by v equals to 5t squared minus 10t. This question looks very nice. So we are given the acceleration of velocity v as 5t squared minus 10t. Okay, they have given us the expression of the velocity at any time t. This is the expression of the velocity at any time t. But now the question says, let's go one at a time, because here we have velocity and acceleration. Let's go one at a time. So velocity, it is saying at what instant is the velocity 0 for the first case. Okay, at what instant is the velocity 0? At the same time, at what instant is the acceleration 0 in a motion that is defined by velocity? What can we do here? Now, for velocity equals to 0 meters per second, by the way. This is the implication that if the velocity is 0 meters per second, what is the time when the velocity is 0, okay, of that motion? What is the time? At what instance means at what times. Okay, so for the velocity equals to 0, what is the time? We simply come and substitute for the velocity as 0, and then we get the time, which we are calling the instant. Therefore, velocity is 0. Substitute for 0 there. 0 equals to 5t squared minus 10t. And clearly this is a quadratic equation that you can solve by any method which you want. I'm going to factorize 0 equals to, if we factorize this, it gives us 5t into t minus 2. If you don't know how to factorize, please go back to Senior 2 and watch our playlist. Or you can contact us and we shall assign for you a tutor to guide you through. Now, either, that is not what we know, either this is a quadratic equation, so there are two roots. Either 5t equals to 0, and in this case t, you write it down here, and therefore in this case t equals to 0 second, or t minus 5 equals to, either 5t equals to 0, therefore t is 0, or t minus 2 is 0, and in this case now our t is 2 seconds. Okay, now for the two values of t, the velocity is 0. How? If we substitute for t as 0 here, we find that v equals to 0. If we substitute for t as 2 in the expression for velocity, we find the velocity is 0. So the velocity is 0 when, so the velocity is 0 when x, it is not x in this case, it is t, when t equals to 0 seconds and or, okay, when t equals to 0 seconds and we use and t equals to 2 seconds. These are the two instances for velocity to be 0. That is the one for velocity. Okay, so the instance when the velocity is 0 is when the time is 0 and when the time is 2. Now let's go to acceleration. Let's get the instance when the acceleration is 0 meters per square second. Let's get the time when the acceleration is 0. Now, for us to get the time, we need the expression for acceleration at any time t. Okay, we need the expression for acceleration at any time t. What is acceleration? Acceleration is the rate of change of velocity, which is dv dt. We have the expression for velocity as 5t squared minus 10t. So we can find the vdt here. It gives us the expression for acceleration. So therefore, the vdt equals to, come and differentiate the given function of velocity. This gives us the 10t minus 10. Okay, this is the expression for the rate of change of velocity, which is the definition of acceleration. Therefore, acceleration A at any time t is given by 10t minus 10. That is the expression for acceleration at any time t. Now, at what instant is the acceleration 0? In other words, at what time is the acceleration 0? That means we shall substitute for acceleration as 0, then we'll look for the time when it is 0. This implies that our acceleration A is 0. So we say 0 equals to 10t minus 10. And then you make t the subject of the formula. Okay. So we shall have 10 equals to 10t. Both sides by 10. So 1 equals to t. Therefore, the time is 1 second. That means when the time is 1 second, when the time of the motion is 1 second, the acceleration of that particle is 0. How do we verify? Simply substitute for 1 in the expression for acceleration at any time t. So that if we substitute for 1 here, 10 times 1 is 10. 10 minus 10 is 0. That is the instant when the acceleration is 0. Therefore, the acceleration is 0 when the time t equals to 1 second, or at time t equals to 1 second. So this is the solution to part B and part C, and that is the overall solution to example 2. Thank you.